Alright, hello Trig and welcome to the chapter review. So the worksheet for the review is posted in the description of the assignment in Google Classroom. What I would suggest you do is go ahead and try working through those problems on your own, and then go to the Jamboard and double check your answers, and then if there's still something you're stuck on, go ahead and come back to the video so that you don't end up watching like however long video this ends up being if you really only need help with one or two of these problems. Alright, so hopefully you've gone and done that. And now back to number one. So number one, we're going to start off by squaring to get rid of that square root. A squared is 64. And the only thing that does over here is cancel out your square root. So you still got a 4x plus 12 over here. And then we're going to get rid of adding 12 by subtracting 12. These are gone. We've got 52 over here. And then we're getting rid of multiplying by dividing. And 52 divided by 4 gets you 13. And this one, since we've got square roots going on, we want to go back, double check our answer, plug it back in. So we've got 13. 13 times 4 gets you 52. 52 plus 12 gets you 64. And sure, the square root of 64 is 8. So we're going back, plugging in the name, making sure that our answer works out. All right. Same sort of thing here, just with one extra step at the beginning. We're going to get rid of that subtracting 5 over there by adding 5. So we're going to add 5. We're going to add 5. These are gone. That gives you another 8. Or not like 8, so I was making this. And then we're back to squaring both sides to get rid of your square root. These are gone. 8 squared is 64. And we got x minus 12. And we're going to add 12. And we're going to add 12. These are gone. We got 76. And if we want to double check that, we can take 76, plug it back in. 76 minus 12 is 64. Squared 64 is 8. 8 minus 3, sure enough. 8 minus 5 gives you 3. Also true numbers. 8 minus 2 would give you 5. Alright, this is where it gets a little bit more complicated. So when we're squaring this one, we want to make sure we're remembering to square this whole thing on the other side. So we're squaring that entire x plus 3. So over here, that's just going to cancel out our square root. We've got a 14x plus 2. Over here, that means we're foiling this x plus 3. So this is really an x plus 3 times an x plus 3. And really the big thing with that is remembering that that's what we're doing, and we're not just going, oh, that's an x squared and a 9, right? Nope, gotta remember to FOIL the whole thing. We do have an x squared, and we do have a 9, but we also got this stuff in between. We got this 3x, we got sub 3x, and we got this 9. And again, if that's a step you can do in your head without having to write out that in-between step, that is 100% fine. Alright, now we're going to go ahead and scoot everything over to one side of our equation. So we've got this x squared over here. I'm going to subtract a 14x and a 2. So 3x and 3x is 6x. 6x minus 14x gets you negative 8x. And 9 minus 2 is 7. Now, if you happen to realize here that this one is going to factor nicely, then yay. Factors of 7, that'll give us 8. Sounds like 7 and 1 to me. Those are really your only factors of 7. And in order to get a negative 8, we're going to need both of those to be negative. So negative 7 and a negative 1 adds up to a negative 8, multiplies to a positive 7. We're good. And then we're going to set those both equal to 0 and solve. And again, if this is a part you can do in your head, like you know pattern by now, okay, this is going to give me a positive 7, this is going to give me a positive 1. That's fine. I'm just going to write out that in-between step. And then we're going to go back, double check those answers, plug them in, make sure they give us what we're looking for. So if we take 7, plug it back in, we get 7 plus 3 is 10. 10 squared, oops, didn't square that time. 7 plus 3 is 10. 7 times 14 is 98. 98 plus 2 is 100. So that one checks out, because the square root of 100 is 10. And then if we plug in 1, 1 plus 3 is 4. 1 times 14 is 14, plus 2 gives us 16. Square root of 16 is 4. That one also double checks out. So this one, they both worked. Yay! It's nice when they both work out. Alright, let's draw more of those. So we're going to square this. We're going to square that. Over here we've got an x squared plus a 2x plus a 2x plus a 4. Because we followed this. Just can't skip that step. Equals this 4 plus a 12x. Okay, we're going to just scooch everything over to one side. Minus 4, minus 4. Ooh, that's nice. Minus this 12x. Minus this 12x. These 4's are gone, so are these 4's. And then we've got these are gone, and 2x plus 2x is 4x. Minus 12x gives you a negative 8x. So now we got this. Okay. Now, if we're factoring this, both of these terms have an x. So instead of turning this into two sets of parentheses with our binomial factors, we're going to just factor out an x here. So we got an x and an x minus 8. Which means that either x is 0 or x minus 8 is 0, which would give you x equals 8. I probably shouldn't have circled that yet because we do want to go back and plug them in and double check. So if we take 0 plus 2, that's 2. 0 times 12 is 0, plus 4 is 4, square root of 4 is 2. That one checks out. And then, whoops. And then if we're plugging in 8, 8 plus 2 is 10. 8 times 12 is 96. 96 plus 4 is 100. Square root of 100 is, sure enough, that's 10. You can both work that out. Okay, so that's it for the square root equation ones. On to the dividing polynomials ones. And these ones were the ones that you could either do by long division, but most of us seem to prefer doing with the synthetic division, so I'm going to do that on these first couple of these until we get the ones where we can't. So if we're doing it this way, we're plugging in that 5 there, so again we want the opposite of whatever's inside our parentheses. So if it's a minus 5, we want a plus 5. If that was a plus 5, we want a negative 5. And then on the outside, we've got our coefficients here. So we've got this 2, this negative 6, negative 27, and 35. And just watch out for those negatives. So we just need to not lose those. So we got a 2, we got a negative 6, we got a negative 27, we got a positive 35. Right. And your first number comes down. And then we're multiplying. And remember, we're multiplying by whatever is inside our box here. So we're taking this 2 times 5, which gets you 10. And then we're adding those. Probably put that there. We're adding those. So negative 6 plus a positive 10 gets you 4. 4 times 5 gets you 20. Negative 27 plus 20 gets you negative 7. Negative 7 times 5 gives you negative 35. And ooh, this one factored nicely. Yay. It's nice to factor nicely because that gives you a 0. And then remember, we're going to plug our x's back in, starting with 1 power smaller than the biggest power we had up here. So if we had a 3 up here, we're going to start off with a 2. So this is going to be a 2x squared plus a 4x, technically x to the first, but you don't need to write that first. And then minus the 7. And then since we have a 0 in our remainder, we don't need to do anything with our remainder term, so that's just going to stay. All right. Same sort of thing here, just one extra thing to watch out for. Do you see it? We're missing a term. So we've got an x to the 4th, we've got an x to the 3rd, we're missing our x squared term. And again, the big thing there is just realizing that that's a thing that we're missing. So rather than just going and plugging in 3 and negative 2 and 5 and 8, we're missing a plus 0x squared term there. And the big thing is just remembering to look for that. So we've got a negative 1 inside our box. And on the outside, we've got that 3. We've got a negative 2. Again, watch out for negatives. And then we have that 0. That's our placeholder there. And we've got a 5. And we've got a negative 8. Cool. And then we're doing the same thing. So that 3 is coming down. 3 times negative 1 is negative 3. Negative 3 plus negative 2 is negative 5. Times a negative 1 is 5. Plus 0 is 5. times negative 1 is negative 5. 5 plus negative 5 is 0. 0 times negative 1 is 0. Plus a negative 8 gets you negative 8. Just added those pluses in. Okay, and then again, we're filling in our variables starting with 1 power smaller than our degree up here. So if we started off with an x to the 4th up there, then we've got a 3x to the 3rd here, minus a 5x squared, plus a 5x technically to the 1st. And that 0 is our constant term, but you don't need to write it in there. Now, if you wrote in a plus 0, that's fine. It's not going to hurt anything. And then we've got a minus that 8 over the thing we were dividing by in the first place, which was our x plus 1. So if you left that 0 term off there, that's fine. If you went ahead and stuck a plus 0 in there, that's okay. Not a difference. Okay. Alright, same sort of thing here, but one extra step first, because we said the synthetic division with the box thing only works if we have an x plus something or an x minus something here. So before I put everything in a box, we're going to go ahead and divide by that 2. And when you're doing that, we want to remember we're dividing everything by 2. So everything over here and everything over here. And again, the big thing there is just remember that that's a thing. So that's a thing we need to do before we start putting anything in a box. So over here we've got a 3x to the 3rd now, plus a 3.5 or 7 halves if you like, x squared, minus a 9x plus 4 divided by, and now this is an x plus 2.5. Cool. And that's what's going in our box. So that negative 2.5 is going in our box. And when we're grabbing our coefficients, we'll make sure we're grabbing these ones, not these ones. So we're taking this 3, and this 3.5, and this negative 9, and this positive 4. And those are the ones that are going here. So these ones, not these ones. And watch out for don't lose any negatives when you're going from here to here or when you're going from here to here. Nice thing is, once we're there, it's the same thing we're just doing. So this 3 is coming down. 3 times negative 2.5 is negative 7.5. Plus positive 3.5 is a negative 4. Negative 4 times negative 2.5 is a positive 10. Negative 9 plus a positive 10 is 1. 1 times negative 2.5 is negative 2.5. Plus 4 gets you 1.5. Cool. Now we're going to go back and plug in our exponents. So we had an x to the 3rd up there, so this is going to be a 3x squared minus a 4x plus a 1. And then plus that 1.5 over either this, or if you want to get back to this, then we're taking it times 2. So it's okay if you left it like this. I'm not going to be picky about that, but technically if we don't want any decimals inside of our fractions, we can go and take that part times 2, and that'll get you back to a 3 over a 2x plus 5. So either this or this. This is the main idea. The fraction inside your decimal inside your fraction thing is not a thing I'm going to be picky about. So technically this, but this wouldn't be wrong. Okay, these are the ones where we do want to go with the long division thing because we have an x squared term over here that we can't put inside of our box. So if we want our long division, we've got an x squared plus a 2x plus 3. And then this stuff is going on the inside here. So we've got an x to the 4th plus an x to the 3rd plus a 6x squared plus a 7x plus that 8. Alright, and then first thing we're looking for is how many times that x squared goes into our x to the 4th. So we're really looking for what's x to the 4th divided by x squared. And if we're dividing monomials with some exponents there, we're taking our exponents and subtracting them. So x to the 4th minus divided by an x squared gives you x squared. And then we're taking that times everything that's over here. So x squared times x squared gets us an x to the 4th. just like 1. X squared times 2x is a 2x to the third. X squared times 3 is 3x squared. And then we're subtracting all of that. These are gone. X cubed minus a 2x cubed is a 1x cubed, negative. 6x squared minus 3x squared is 3x squared. And the rest of it's coming on down. And then we're going to do it again. So we're looking for how many times does x squared go into a negative x cubed, and that's going to be a negative x. So again, we're really looking for there what's a negative x cubed divided by x squared. And x cubed divided by x squared is going to be x to the first, and then negatives just hanging out. Now, if you want to put a negative 1 in front of there for fun, you can also do that. It's not going to hurt anything. It's not really going to do anything either. So that can either be there or not. And then we're taking that negative x, and watch out for we are taking that negative times all of this stuff too. So that's going to be a negative x cubed. And this is going to be a negative 2x squared. And that's going to be a negative 3x. And then we're subtracting all of that. So when you're doing that, just watch out for don't lose any of those negatives. So multiplying that negative by that whole thing there. Right. These are gone. 3x squared minus a negative 2x squared is going to be a 5x squared, which is why you don't want to lose any of those negatives. 7x minus a negative 3x is going to be a positive 10x. And then that 8 is coming on down. All right, last one. Now we're looking for how many times does x squared go into 5x squared, which is just going to be a 5 there. So plus 5. And then we're taking that 5 times all of this stuff. So 5 times x squared is a 5x squared. 5 times 2x is 10x. Ooh, that's pretty nice. And 5 times 3 is 15. So these are gone. These are gone. So our remainder is just 8 minus 15, which is a negative 7. So that negative 7 is going to come up here on top of the thing we were dividing by in the first place. Okay, so I'm just going to put that down there. So it's a little bit easier to see. So we got x squared minus x plus that 5. And then either plus a negative 7 over that x squared plus whatever it was, plus 2x plus 3. So if you put that as plus a negative 7, that's fine. If you put it as a minus 7, that's fine. One or the other. Either one's okay. All right. All right, these things. So if we want to determine whether each of the following is a factor of that, factors were things that divided out nicely and evenly and didn't give us a remainder. So what we're looking for here is, do we get a remainder when we divide by them? So if we're looking at that first one, I'm just going to go ahead and put that negative 4 in box. And we've got a 1, and a negative 3, and a negative 18, and a positive 40 on the outside. Show us myself a little more room there. I like it. Then the 1's coming down. 1 times negative 4 is negative 4. Negative 3 and negative 4 gives you negative 7. Negative 4 times a negative 7 is a positive 28. Negative 18 plus a positive 28 is 10. Negative 4 times 10 is negative 40. And 40 and negative 40 gives you 0. And this one we don't actually have to go back and plug the variables back in, because all we were looking for was, do we have a remainder? And no, we don't. So yes, this is a factor. Ha, caught that. Okay, almost dropped that. Caught it. So yeah, that was a factor. The reason you might actually want to go and plug those variables back in is now that we have one factor, we don't actually have to go through and do this with the others. Now we're just looking for, does this factor out into those? So would that factor out into an x minus 5 and an x minus 2? Ooh, yes, it does. Because 5 times 2 gets you 10, negative 5 plus a negative 2 gets you that negative 7. So yeah, these are all factors. Now, if you went through and double checked that by doing this and all of them, that's fine. It's just a little bit of extra time that I'm not going to take because this is almost 20 minutes already. Okay, So we're going to scroll over here now. Actually, we're going to scroll to the next page. And we're going to jump to these. So these are the ones where we were looking for our common denominator here. So if we want a common denominator, that'd be at x minus 4. And then we're just going to take everything times that. So we're looking for the least common multiple of our denominators and then just multiplying everything by that thing. So that thing in this case is just x minus 4. So we're going to take this times x minus 4. And we're going to take this times x minus 4. And we're going to take this times an x minus 4, but the nice thing is most of those are about to cancel. So these x minus 4s will cancel. These x minus 4s will cancel, and now all of our fractions are gone, which was the point there. So now I got that 3 times an x minus 4 minus that 5 equals that 2. And then we're going to distribute that. So once we've gotten rid of our fractions, we're really just solving for x, just like we've been doing since like 7th grade. I think we can do this part. So we got a 3x minus that 17 there equals this 2. We're going to add 17. We're going to add 17. These are gone. 2 plus 17 is 19, and we're dividing by 3. And if you left that as 19/3, that's fine. If you're a decimal fan and you called that 6.3 repeating, that's also fine. Either or, so either this or this. Cool. And then since we got fractions, the last thing we want to do is go back and double check and make sure that's not going to give us 0 on the bottom of our fractions. And sure enough, 6.3 repeating minus 4 is not going to give you 0. Yay. Cool. Okay, so the first thing we're looking for if we got an x squared term here is our factors. And if you're looking for factors, a good place to start is with your denominators that you have over here. So it'd be really nice if this factored into both of these. And if we're looking at those, yes it does, because if we have an x plus 1 and an x minus 2, our positive 1 and our negative 2 will get us that negative 1x, and then positive 1 times a negative 2 will get us that negative 2 there. So this time those check out. So if you're looking for factors, these other terms are a good place to start. So that means we're taking everything times both of those. So we're taking this times an x plus 1 and an x minus 2, and an x plus 1 and an x minus 2, and an x plus 1 and an x minus 2. Which looks like a big mess, but most of it's about to cancel itself out, because now we've got these that are canceling, and these x minus 2s are canceling, and both of these are canceling. And this came from this in the first place, so all of our denominators are gone, which again was the point here. So we're taking that 1 times an x minus 2 plus this 2 times that x plus 1 equals everything that was on the top over here. And then we're just making some of this look nice. So we're distributing this, and then we're combining some like terms. And x minus 2. Nicely, these are gone. 1x plus a 2x is a 3x, so we're just going to subtract the 3x over here. Now watch out for these ones aren't canceling, because both of these are negative. So a negative 3x minus another 3x gets you minus 6x plus that 5. And I'm just going to scoot that 0 over here instead, just because it looks nice. Now, this, again, it'd be nice if these factored, and oh, yes, they do. Because if we're looking for factors of 5, that'll give you 6. 5 and 1 are really your only factors of 5. And if they're both negative, that gets us that minus 6 that we want there. Yeah. So again, x equals 1, and again, x equals 5. And again, if we got fractions, we just want to go back and double check and make sure that they're not going to give us 0 on the bottom of either of those fractions. So if we plug in 1, 1 plus 1 isn't 0, 1 minus 2 isn't 0, 5 plus 1 isn't 0, 5 minus 2 isn't 0. So both of those check out. Check, check, yay. Okay, these are the most recent thing we were doing here. So if we got some inequalities instead, we're going to start off with factoring just like we would if that was an equal sign. So if that was an equal sign, we'd take an x minus 6, and an x plus 2 would give us that negative 4 when we add them, negative 12 when we subtract them. Okay, now, those are our x-intercepts. So if we're thinking about this as a parabola, this means we've got an x-intercept at negative 2 and an x-intercept at a positive 6. And again, we know this one's a parabola because we've got an x squared. Our parabola is facing this way because it's a positive x squared. So then if we're looking for where that's greater than 0, there are two parts on our graph where that's greater than 0. We've got this part over here, and we got this part over here. So we've got this first part where x is less than negative 2, and this other part where x is greater than 6. Or again, if you want that in interval notation, you could also write that as negative infinity to negative 2 and 6 up to infinity. So I'm not going to be picky about the notation there, either this or this, either one's fine. Right. This one. First thing we want to do here, and big thing there again is remember that this is the thing we want to do first, is we want to scoot that 1 over here. So I scoot this. Because what we're about to do with the x-intercepts only works if this is a 0 over here. So now we're going to get a common denominator for our fractions. So we're going to take this times an x minus 3 over an x minus 3. So on top we got an x plus 4 plus this x minus 3. We're saying that times 1 over this x minus 3. And we're going to simplify that a little bit, combine some like terms. So 1x plus 1x is a 2x. 4 minus 3 is 1. Okay. And then again, what we're looking for here is we're looking for two things. We're looking for our x-intercepts, just like we were looking for over here, but we're also keeping an eye out for asymptotes, because those are the two options for where our rational function could be either changing from positive to negative or negative to positive. It could be an x-intercept or it could be an asymptote. So we've got an asymptote at x equals 3, and again, our asymptotes are coming from what's making the bottom of our fraction equal 0. So if x minus 3 equals 0, then x is 3. And our x-intercepts are coming from what makes the top of our fraction equal 0. So if we want 2x plus 1 to equal 0, we're subtracting 1. You can probably do this in your head. We're divided by 2. And again, x is a negative 1/2. So those are the 2 points we're interested in, although I probably shouldn't circle them because that's not the answer. So those are the 2 points that are going on our number line. We've got a negative 1/2, we've got a positive 3. Now, unless you happen to know what this graph is going to look like off the top of your head, because back here we knew this was a parabola. We've been looking at parabolas since like 8th grade. If you don't know off the top of your head what that graph's going to look like, then we're probably going to want to plug in some numbers. So I don't know about you, but I don't know off the top of my head what that graph looks like. So if we're going to plug in something, a good thing to plug in is going to be 0. So if we plug in 0, that's right between here. So we're plugging in 0. 0 times 2 is 0, plus 1 is 1. 0 minus 3 is negative 3. That's negative, so I'm just going to jot down that part of our graph is negative. Now, if you happen to remember that as long as we don't have anything going on with double roots, if we have negative here, these are both going to be positive, that's fine. If you went ahead and plugged some things in to double check, that's fine. So if we plug in a negative 1, we've got a 2 times a negative 1 is negative 2, plus 1 over negative 1 minus 3 is negative 4. So if we have a negative over a negative, that's going to be positive. And if you plug in something over here, like say 4, we got 2 times 4 plus 1 over 4 minus 3. That's positive over positive. And again, the big thing in here isn't what is that number, it's just is that number positive or is that number negative. So as soon as we know this is positive, we don't need to map that all the way out. And since we're looking for where this is greater than 0, we're looking for the parts of our graph where we're positive. So we're looking for this section, and we're looking for this section. And again, we just want to write that in a way that's not just circling that part on our number line. I can talk tonight. So we've got this part over here where x is less than negative 1/2. And we've got this part over here where x is greater than 3. Or again, if you're fond of integral notation, you could also write that like this. So either this or this, I'm not going to be picky about the notation. Getting here is the main thing. All right, almost done. We want a polynomial function with zeros at 8, -5, and 1. And the quickest way to get a polynomial function with zeros at 8, -5, and 1 is to write it like this. So you could go ahead and write it out with an x cubed and an x squared and try to finagle it until you get your zeros there. It's probably going to be easier if we just put our factors there to begin with. So if one of these things is an x minus 8, that'll give us an x-intercept at 8. If we have an x plus 5 here, that'll give us an x-intercept at -5. If we have an x minus 1 here, that'll have an x-intercept at 1. Now, you could add some more other stuff in here. You could like square this, give yourself a double root. You could throw some numbers out here, but this is the minimum that we would need there. So you can make it fancier if you want, and this is what we're looking for. If you want to put a number out here, that's fine. If you want to square some of those, that's fine. And again, technically, since I didn't say those are the only zeros, you could add some more things in there. Okay, if we want a degree of 4 and 2 x-intercepts, a couple ways to get that. So we could get that by doing what we were just doing there and saying if we want a degree of 4, that means we got 4 of these factors. And if we only want 2 x-intercepts, that means we've got some multiples going on here. So if I put one at like x plus 5, and let's say x minus 2, that means the others just need to be repeats of those. So we could go x minus 2 and another x minus 2, and that would give you 2 x-intercepts because these three are all the same x-intercept. Now, you could also write that like this. So as soon as you got those first two, you can just throw some exponents on them and make sure that your exponents add up to 4, because that's definitely a 1 there if we don't have one. That's one way to get it. The other thing you could do is to say if we want a degree of 4, if we don't have anything there, then that graph is going something like this, kind of like a squashy parabola there. So if we want that to have 2 x-intercepts, one thing you could do is you could just take that and scoot it down. So if we want to scoot it down, we could just subtract, let's say, 1. Boom, that's a 4th degree polynomial with 2 x-intercepts. So something like this will work, something like this will work. If you wrote this like this instead, that would be fine. So something like these. So those are not the only things that would work. So these things, when you're double checking your answers, this isn't the only option. There are plenty of things that'll work. So if you want to see if your answer works, I would just pull up Desmos, plug it in, and see if you got 2 x-intercepts. All right, oops. 2 more. Okay, and we're sketching. So we're sketching a graph of a polynomial function with a positive leading coefficient and an odd degree. So positive leading coefficient, odd degree. So odd degree polynomials were things that were looking something like this or something like this, depending on whether we have a positive or negative leading coefficient. Now, some of them have some bumps in there, so it might be something like this, or it might be something like this with some bumps, depending on what exactly is in our polynomial, but it's going to have that general shape. So again, we're sketching. So if we want a positive leading coefficient and an odd degree, we're going to end up with something like this. So something where your end behavior is doing this, where you're going off to negative infinity on the left and positive infinity on the right. So it could have some bumps in here, but this general shape. So something like that. Now, if you wanted a negative leading coefficient, then it'd be going down instead. Speaking of negative leading coefficients, if you want a negative leading coefficient and an even degree polynomials, again, either look like this or like this. So if you think about that like an x squared, that's an even degree. Positive leading coefficient, negative leading coefficient. So the simplest thing to draw here would just be a parabola going like that. And again, you could have some bumps in there, but the important thing is the end behavior. So is it going down on both ends? So negative leading coefficient, even degree, something like this. And again, you could have some bumps in there. This is the end behavior is what we're looking for there. Great. So that is it for the chapter review. Feel free to email me if you have any questions. Hopefully having the test sometime soon after we come back from distance learning. So be ready for that. I'll see you next time.